This section is really just memorizing a pattern that they found. They did a bunch of the divisions. The reason why it's in this chapter is because the way they found the pattern is by dividing. They divided this by the binomial that matches it, and then they went, oh, look at this beautiful trinomial that appeared. So by doing a bunch of these divisions, they found a pattern. The pattern that they found is actually comes from, it looks similar to, actually, the difference of squares. So this is also a pattern that we saw. So we've seen this before, a squared minus b squared. A squared minus b squared, we know that that factors to be a minus b, a plus b. And if we want to check that, what we would do is we would just expand it. 1, 2, 3, 4, expand it, it goes back there, right? So by doing a bunch of these, so back in grade 10, we said do a bunch of these. We had the investigation. We said do a bunch of these, and you'll notice that the pattern is that they're two of the same with opposite signs. Then we knew that from here, backwards and forwards, we knew what that meant, right? So that was our difference of squares. They did the same thing, and the way they found it was using division. They did a bunch. They found the pattern, and this is the pattern that they found. So if you're like, why is this in this chapter 3 with all this division stuff? They found this pattern by doing division, right? So they did the division. They said, wait, every time I do this, this is what I found. And then they said, now let's memorize it. So they're saying, let's memorize the pattern. So this is the pattern that they found. They have a cubed minus b cubed. Sorry, it's a little fuzzy there, but a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. We're going to go over this pattern until we kind of get it. So the first thing we want to notice about this pattern is that it's a minus, which matches the minus here. Okay. We notice that this is a binomial, right? Binomial here, and this is a trinomial. So it's a binomial with a trinomial. Okay. Then we look at the next one, and we go, okay, so this one has a plus, which gives me a plus here, but a minus here. So look at the signs. So there's one minus. So if it's a cubed minus b cubed, the minus is first. It matches. Okay. Then it's plus plus. If it's plus first, then the plus matches here. So you'll see, that's kind of how I memorize it. I go, if it's plus in between, then plus is the first. The next one is minus. Then it's minus for the next one. Okay. One more time. The pattern goes a minus b, so it's going to be one of each of the third roots. Then it's the first one squared, so a squared. I multiply the two together, a times b, which gets me ab. And then I have b squared, the last one times itself. Can I factor that trinomial? Does anything, what's the coefficient, multiply to 1 and add to 1? No. It needed to be 2 in the middle. This is not the binomial squared. People always start to forget, but we got this. So a plus b squared is a squared 2ab and b squared. Right? So that's the binomial squared. Don't get these mixed up. Now when I ask you this, sometimes you forget your 2. Okay? This is still the binomial squared. That is not this. That is not the binomial squared. This is first one squared, second one squared, multiply the 2 together in the middle. It's not double. And that is not factorable. Right? So you'll always get this trinomial, which is not factorable. Unless there's a bunch of stuff in the brackets you expand, maybe that's factorable, but by itself multiplies to 1 b squared, adds to 1ab, no. Okay, it's not this. It looks very similar, but don't forget this. This is still the binomial squared with the 2. That is not what this is. Okay? And that trinomial is not factorable. All right, so now let's try to use this pattern. So usually when I get this, I rewrite this. Okay, so just so we can follow this pattern up here. You don't have to rewrite it. I'm going to show you how I rewrite it. So I take this guy and I go like this. I go, this is the same thing as x cubed minus 1 cubed. You don't have to rewrite it, but I'm just showing myself that's actually 1 times 1 times 1, which is why it is a difference of cubes. Okay? So there you go. Again, you don't have to rewrite it. You can go to the next step. You don't have to show this, but visually might help you. Then you go, okay. So from there, I am going to take one of each of them for the short binomial bracket and then I'm going to have a long trinomial bracket. You don't have to set it up first, but sometimes this is what you're thinking in your brain. You're thinking short one, long one, binomial, trinomial. Okay? For the binomial, you take one of each. Okay? You take one of each of them. So what do I mean by one of each? I take one of the x's and one of the ones. So I go x minus 1. And I keep the same sign. Right? So that first one keeps the same sign. Okay. Then, for the trinomial, so it's the binomial, trinomial bracket. So the trinomial, okay, I'm going to cover this up now, and I look at my first bracket. So again, it's just visual to me. So I go square the first, so this times itself, so x squared. Then a times b, so the pattern here is a times b, which is first times last. A times b, which is x times 1, so it'll be x. The sign is only 1 minus. So look up here. There's only 1 minus for the first one. The other two are pluses. Okay, it's a minus, and then the other two are pluses. So we're going to go plus, like that. And then the last times the last. Okay, the last times the last is going to be plus 1. Okay? All right, that's it. Okay. Try it again. Okay, that's it. And that trinomial, can you factor it? You can't. Can't, right? Because it's not enough. There should be a 2 there. It's not. Right? So we know that the trinomial feels like you want to, but you can't. Let's try it again. So again, I like to rewrite it. You don't have to, but it's m cubed plus 2 cubed. Okay, again, if you don't want to, you skip that step. Okay, and it's going to be m plus 2, right? So one of each, right, of the third, right, third root there. I cover that up, and I just look here now. And I keep the sign, right? So one more time. If it's a plus, I keep the plus for the first one. Then, for the second bracket, if it's a plus here, right, I do first times first, so it's m squared. A times b, so multiply each other. A times b, so it'll be 2m. But the sign is minus. Okay, if it's a plus here, the first one here has to be minus. And again, why? Because when you expand it, it actually works. So I'll show you, I'll expand it just so I can prove it to you. And then here, the last times the last is 4. Okay, and again, people go, why? So if I expand this, I'm just going to take it so that I can show you. It's just the pattern that they found after a bunch of divisions. So after they did a bunch of divisions, they went, oh, cool, that's a pattern. So if you expand this out, it's x cubed plus x squared, x times that, plus x, right? And then this one, this one, this one. So minus x squared minus x, and then minus 1. What happens is that these guys, positive x squared minus x squared and plus x, so then you're left with x cubed minus 1. So that's why. So you should be able to expand and collect and then see that it ends up being the beginning again, right? And again, that's the pattern they found. By doing a bunch of divisions, they went, oh, that always happens, and it's a pattern that you can memorize, like it's not too difficult to memorize. Okay, so if you expand that, it should bring you back to the beginning. Does that make sense? All right, so we've got the pattern. That's how we can check if we want to. And really, I wouldn't check if it got longer. We're going to get longer ones, but you can check some of the short ones if you want to. Okay, so let's try it again. So this one here. Again, you don't have to show this step, but sometimes I like it because it goes 5 cubed minus g cubed. Okay, equals. Okay, equals, and then short one, 5 minus g, like that. Okay, 5 minus g. Okay, then, and see I kept the sign, right? I kept the sign. Okay, and then we've got square the first, so I'm going to cover that up. Okay, square the first, so it's 25. a times b, so 5g. The sign is positive, right? So if the first one here is negative, then that's my only negative, and then the rest are positive. And then the last one here, g times g, g squared. Okay? Then we're going to do it again. That's already in cubed form, so you don't have to do that again, right? So you don't have to do anything with that. So it's already in the proper form with the cube. So we're going to just break it apart. So one of each, like that, third root. I cover that up, and I go, okay, if it's a plus first, then I know it's going to be first times first, x squared, a times b, right? Each one times each other, but with a minus, right? So take a look, it's minus. I cover that up just because it distracts me sometimes, and I just go one of each, then each one times each other, xy, xy, and then last times last, so y squared. Okay, that's it. And again, you feel like factoring that trinomial, you can't, right? The middle's just not big enough. All right, keep going. Now, do not forget previous factoring stuff. So yes, common factors can be there as well, right? So we're going to take that common factor out. So don't forget how to do that. So we definitely want to take out the common factor of 7x, right? So then let's do the rest. And we're going to take x cubed minus 64. Okay, again, keep the 7x here. This you can rewrite. You don't have to, but again, if it helps you to do one more step, then rewrite it. Okay, if you don't have to, you don't have to, but you're picturing what the base is, right? And again, after you do a few of these, sometimes you don't want to, but sometimes that helps you. 4 cubed. Right, so the third root of that, of 64, 4 times 4 times 4, is 4. Okay, so we want to take that. Keep the 7x, right? We're still keeping that 7x there in front. Okay, and then now I look at this and I go one of each of the third root, right? So it's going to be an x minus 4. Right, keep the sign, the minus there. Okay, bracket. Okay, and I ignore that now, so I'm just looking first times first, so x squared, 4 times the x, right, 4 times the x, so that'll be 4x, a times b, 1 times each other, and if this is minus, the other two are plus. And then last times last, 16. There you go. And then these last three are just me making the question longer, bigger exponents. I can give you brackets and stuff. Okay, so let's try it again. So this one here, we're going to go with x to the 9 and 512. What's the third root of 512? 8. Yeah, so 8. That one, what's the third root of x to the 9? So this one sometimes throws you off a little. Okay. What is the third root, right? And we know this is 8 to the 3, right? So that's okay. What's the third root of x to the 9? So if I want to put the 3 out there, what do I put inside? X to the 3. Power to power means you multiply. People always say subtract. No, power to power is multiply. So it's 3 times 3 gets me 9. So you can set it up like this. This is the case where I'm like, yeah, sometimes you want to know what the base is. So you want the third root of that. So third root would get me x to the 3, 3 to 3. That's third root of 512 is 8, so 8 to the 3. Right? Again, you don't have to show this, but I do find sometimes it helps you. So do write that step if it helps you. Okay, and then now we're going to do the short and the long. So it's a binomial and the trinomial. So the binomial, one of each of the bases, right? So the base here is x cubed, and the base here is 8, right? So the base here, does that make sense? So we got the x there, and that's what we're putting here. And we're keeping the minus. Right, so the base, yeah.
Could you rewrite the 8 as 2 cubed and then make it
You have to. Not could you rewrite. So the question is, could you do this? Yeah, you're going to do it again. So at the end, if I was to give you a difference of squares, you would say, hey, do you want me to fully factor? Yes. We always, when the instructions are factor, we always imply fully factor as much as possible. So we're going to do this one again because this is a difference of cubes. Yep. So we're going to do that again for sure. If you see that right away, you can go right ahead and do that in one step. But again, you can do it in a separate step. But yeah, that should be screaming at you. You know how the x squared minus 4 is like, hey, I'm a difference of squares? This, you should be like, hey, isn't that something? Is that something? Yeah, we just learned that. Okay, so here, now, so cover that up. So it's first times the first. So it'll be x to the 6, right? So you got to go 3 and 3. Then a times the b, first and the second times each other, it'll be 8x cubed. And because that's a minus, I put plus, right? Plus, and then 8 times 8, 64. And when you look at that, you go, darn, I wish I could do that one. That looks like a trinomial, but it's not enough, right? Because that's 64 and that's 8. But this, we have to keep going. Not could you, you have to. Okay, because otherwise it's not fully factored. So again, you can rewrite it. Okay, if it helps you to rewrite it, then do it. If it doesn't, you don't have to. But if you're going to take one more step and be more accurate, take one more step. Right? Doesn't add too much. So go, okay, the base of that is the x and the 2. All right, and then we're going to go and say, so this is going to be x minus 2, binomial. The trinomial is, so again, we're looking at this, x squared, first times first, a times b, multiply each other, so plus 2x, and then last times last, 4. So that is this. So then write down what's left over. Okay, and that's it. You feel like factoring these trinomials, but again, look, multiplies 4, adds 2, yeah, there's nothing. Good? All right. 2 more times. What can I possibly do to this question? Oh, I can put some fractions in. Yay, fractions are our friends. Fractions with a common. They got 5 there too, and a fraction. And look, brackets. Right? So we can do brackets. We've done these before. When we did difference of squares, we would say, okay, we would do something like this, x plus 2 squared plus m, minus. We would do that, right? Difference of squares with the brackets. So that's this idea here. So we got brackets. All right, so now let's do these last 2. So this one here, first of all, 5. I see the 5 in front, right? Both of them, 5. And 5 also is not a perfect cube, right? So I definitely couldn't work with the 5. So let's do a common factor of 5. I'm going to write it further to the left just because I realize that this one needs a bit more room because of the bracket. So I'm going to kind of write it way over here just so I have a bit more room. Okay, so I'm going to move it over here just because this guy takes a bit more room. Okay, so here I'm going to take out the 5 and I'll write what's left over. So this will be, you can write 1 over 8 or you can put x to the 6 over 8. I'll accept either because the fraction was already written in front like that, so I don't mind either way. Okay, some people would be like, oh, I like to write it on top. That's up to you. So you can write it in front or under. Okay, so you can write x to the 6 over 8 or 1/8 x to the 6. Doesn't matter. Okay, so that's me taking out the 5. Now I need to look for the third root of each one of these. So what we're picturing, so I'll write the 5. I'm going to do this. And we're going to go. I need this to the power of 3 plus this to the power of 3. You don't have to put the double brackets, but I'm just emphasizing what I'm trying to do. I'm trying to get the third root of each one of these 2 terms. Okay, and again, you don't have to show this, but I like it just so I can say what's the third root of the 1/8 x to the 6. For the 1/8, it's 1 over 2, right? 2 times 2 times 2 is 8. So that's 2 times 2 times 2. For the x to the what? To the 3, right? When you're doing to the 3 there, it's going to be 2. X squared. Right? 2 times 3 is 6. Think of it backwards. 2 times 3 is 6. That's x squared. Okay. What about the y? Y to the, what would it be? If I know it's 12, I'm dividing by the 3, so 4. Right? 12 divided by. Good? Okay, so I do that. Again, some people don't do that. I like to visually see what my bases are. So now would I see what my third roots are? I'm going to still keep the 5. Don't lose my common factor 5. And then again, it's going to be a short binomial and then a longer trinomial. So for my binomial, it's going to be one of each of those third roots. Right? So one of each is going to be 1/2 x squared. Right? 1/2 x squared plus y to the 4. Does that make sense? Okay, so 1/2 with the x squared there. Okay, so that base and y to the 4. Once I see that, I cover up this just visually for myself or just ignore it and go now. I need the next pattern. The trinomial is going to be the first one squared. So the first one times itself. So this will be 1/2 times 1/2 is 1/4. X squared times x squared is x to the 4. Okay. The sign in between has to be minus because it was plus here. So it's minus there. Okay. And then I want a times b. I want the first times the second one. 1/2 x squared times y to the 4 is just 1/2 x squared y to the 4. There's nothing I can cancel, nothing I can do. Plus, and then last times last, y to the 8. That's it. All right, next one. Okay, last one. So this last one, again, I can see a common factor of 2. So I'm going to take out a common factor of 2 first. So common factor of 2, I'm just putting a line so you can try and keep my notes neat for you. Okay, so common factor of 2. So I'm writing it over here just because I know that it's longer. I put it too close to this side because I've got the brackets there. So I'm just going to I'm going to write it over here a little bit to the left. Okay? So I'm going to take out the 2. And let's write down what's left over. So then I'm going to use a square bracket because there's already a round bracket. You can use double round. It doesn't matter. And I'm going to go m plus 2 cubed plus 64n cubed. Okay. Going to rewrite it. Again, I like this step, but you don't have to. I just like it because it helps me center what my base is. So this already is cubed. So that's good. That's already in cube form there. Plus this. I need the whole thing cubed. So that would be 64. The third root of 64 is 4. So this is 4n all cubed. Okay, again, you don't have to. I like to visualize. So then I got the base, the third root of each one, and then now I can go ahead. Keep the 2 in front, and we're going to do a binomial and a trinomial. It's going to be longer because it's already a double bracket there. Okay, so this first one here, it's going to be, I could have used the square bracket again. So too late. So it'll be m plus 2 plus 4n. Did I need brackets on those? No. So if you see that right away, you can drop it right away. If you're like, oh, I wrote it, you can get rid of it next step. Okay, I didn't need any brackets because it's plus and there's nothing being multiplied. If you put it and you get rid of it next step, that's fine. Just make sure you clean up the brackets at the end, right? And if you could see it right away, you could have taken it away right away. But if not, make sure you clean it at the end. Okay, so that's one of each. Then I ignore this and I go, okay, for the second bracket here, first times first, so it'll be m plus 2 squared. Yes, you need the bracket there because you're doing the whole binomial squared. Okay. If this is plus, this has to be minus. Then you do a times b or b times a. I'm going to put the monomial in front. I just like it better in terms of distributive. Okay, same difference if you put it behind or in front. I usually put it in front. Right, so a times b or b times a plus, and then 4n. Do you need the bracket here? Yes. Okay, typically people just forget and you go, oh, it's 4n squared, but you need the bracket here. So I'm just going to highlight that just a little. Okay, so these guys, you have to have the bracket. Here, didn't need the bracket. Yes, obviously here you did, right? But these guys you have to watch out. Okay, if you don't have the bracket, you put 4n squared, you're losing that mark because you don't know what the base was. Yeah, we have to keep going. Oh, we're not going to leave it like this. There are too many extra brackets. So just like when we used to give you these guys here in grade 10, we didn't let you leave it like this. We said you can't leave it, right? We did this. You always do that. So since grade 10, we've said finish it. So you have to finish that. So, yes.
Miss, would you want us to write down the stuff, or could we go like...
You can skip it. Yep, yep. Yep, so if you can do more in your head, that's fine. Yeah, so question is to skip. You can skip some steps, definitely. Here, again, if you saw that right away, you could have just taken it right out. I don't care about the order because there's a single m, a single n, and a number. I don't care if you do m and then n and then the number. It's fine with me. Okay? Here, you do have to expand this. So please, please don't forget your old expanding. This is where you guys lose your minds. And you're like, oh, wait, what? 2, no 2, 2, no 2. Wait, you know what this is, right? So this is m squared plus 2 times m, 2 times 4m plus 4. It's different. This is a binomial squared. What we're doing is a different pattern. So don't get the two patterns mixed up. You know this. That's m squared, 4m, 4. Then you distribute this guy, minus 4mn, minus 8n, and then plus 16n squared. And you are all done. I have no like terms. I just gave you a bunch of letters, variables. Don't gather up. But that's better because